Hello, and welcome to The Shy Scientist, a quiet place where wonder meets stillness, and science gently guides you towards sleep. Before we set out on tonight's journey, tell me in the comments, where in the world are you watching from, and what time is it there? It always amazes me how many of us drift together from so many corners of Earth. And if this voyage brings you peace, a gentle like and a soft subscribe will help you join me again for our next stargazing session. Tonight, we'll explore how galaxies, those vast cities of stars first, emerged out of darkness and dust. I hope it relaxes you more than it excites you. But if your mind does stay awake, at least it will wander through the early universe before your morning coffee. So, breathe deeply, let your shoulders fall, and allow the cosmos to unfold. Billions of years ago, the universe was impossibly small, hotter than a star's core, and denser than anything we can truly picture. Then came expansion, not an explosion, but a rapid, graceful swelling of space itself. In those first fleeting instants, the universe was a storm of particles and energy, yet out of the chaos, simple atoms hydrogen and helium began to form. After about 380,000 years, the universe cooled enough for light to travel freely. This soft afterglow, the cosmic microwave background, still hums across space today. But despite that glow, the cosmos was dark. No stars, no galaxies, just clouds of gas waiting for gravity's quiet hand. Over immense stretches of time, tiny ripples of matter thickened. Gravity gathered them into clumps, the seeds of galaxies. For hundreds of millions of years, the universe remained in shadow a long breath before the first light. Then at last, gravity compressed hydrogen into such density that fusion ignited. The very first stars were born. These stars were unlike any we know today, massive, blazing, and short-lived. Their light pierced the ancient fog, slowly making the universe transparent again. With their fiery deaths, they spread heavier elements, carbon, oxygen, iron, seeding the next generations of stars and, eventually, galaxies. Though we cannot see those earliest suns directly, we trace their story in the faint signatures of ancient light. And now, with telescopes like James Webb, we're glimpsing small, chaotic galaxies that flickered into being not long after the Big Bang. Their light has traveled across billions of years, through collisions and black holes, through the growth of the Milky Way, to arrive softly here, where you listen now on a quiet evening, as the first dawn of the cosmos drifts you toward rest. The universe, once silent and dark, had lit its first lanterns. The age of galaxies had begun. Everywhere in the young universe, clusters of stars were gathering. Gravity pulled them together, stitching small groups into larger ones. Villages became towns, and towns grew into the first rough drafts of galaxies. It wasn't neat or orderly. Collisions, mergers, and chaos shaped the scene. Gas clouds slammed together. Stars were scattered, and some galaxies thrived, while others remained faint and isolated. These early systems weren't graceful spirals or smooth ellipticals, more like uneven clumps, messy but growing. All of this unfolded inside a larger pattern, the cosmic web. Imagine a vast three-dimensional lace stretched across the universe. At dense intersections of dark matter and gas, galaxies clustered and collided. Their gravity-twisted shapes pulled out long trails of stars and triggered bursts of new star formation. Amid destruction, creation bloomed. Over time, galaxies found identities. Some, with steady spin, flattened into spirals like our Milky Way. Others, battered by encounters, became round ellipticals. Few never settled at all, staying irregular and patchy. Yet every type shared the same role: starforges, recycling gas into generations of suns. Scattering elements that would one day form planets and life, galaxies themselves also gathered into communities, clusters and groups bound by gravity. Our own Milky Way belongs to one, sharing space with Andromeda, Triangulum, and many smaller companions. By this stage, the universe had changed. No longer just a sea of gas and scattered light, it had structure, neighborhoods, and brilliant star cities. Darkness still lingered, but it was no longer empty. Galaxies had begun to shape the cosmos into something lasting. Galaxies are as diverse as snowflakes, though. Instead of ice, they hold hundreds of billions of stars. Some spin gracefully like cosmic pinwheels, Others puff out into round clouds, and a few look like chaotic sketches drawn in the dark. But why do they take such different forms? The answer lies in gravity, motion, and time. Spiral galaxies are the beauties of the cosmos. Their rotating disks flatten into elegant swirls, with waves of density creating arms where new stars ignite. These galaxies stay lively, filled with gas and dust, giving birth to bright young stars. Our Milky Way is one of them, a vast rotating city where we live on the quiet outskirts. Ellipticals, in contrast, are rounder and calmer. They're built largely from collisions. When two spirals merge, their orderly spin is lost, gas is consumed, and the result is a massive ball of older stars. They're the retirement homes of the universe, stable but no longer rich in star-making material. Then there are irregulars, the wildcards. Some are young galaxies still settling into shape, while others are distorted by neighbors tugging them out of alignment. They may look untidy, but many are bursting with fresh stars and energy. A galaxy's shape is more than appearance, it records its history. Spirals usually had gentler pasts, ellipticals lived through violent mergers, and irregulars often got unlucky. Nothing is final. Galaxies still collide, transform, and reshape themselves over time. The Hubble telescope revealed this incredible variety, capturing galaxies in every stage, from newborn clusters to ancient giants. Each shape tells a story of billions of years, of stars being born, living, and fading away. And of course, our own home is part of this grand story. The Milky Way is a sprawling spiral, about 100,000 light years across and filled with hundreds of billions of stars. From inside, we see it as a glowing river across the night sky. At its heart lies Sagittarius A*, a supermassive black hole 4,000,000 times the mass of our Sun. We can't see it directly, but we watch its gravity fling stars around in dizzying orbits. The Milky Way grew through countless mergers, swallowing smaller galaxies along the way. Some of their stars still linger on its edges, silent reminders of ancient collisions. Even now, our galaxy is slowly absorbing companions, blending them in over millions of years. Every galaxy's spiral, elliptical, or irregular is both a structure of stars and a record of time. They're not static pictures, but living, changing systems. And in their light, we read the history of the universe itself. The Milky Way isn't as permanent as it looks. In fact, it's slowly heading for a cosmic meeting with our nearest large neighbor, the Andromeda galaxy. Right now, it's about 2.5 million light-years away, moving toward us at over 100 kilometers per second. Sounds scary, but don't panic. You've got roughly 4 billion years before it happens, and when it does, it won't be fiery destruction. Instead, the two galaxies will merge, likely forming a giant new elliptical system. Astronomers even gave it a nickname, Milky Way. How do we know all this while sitting inside the Milky Way? Through radio waves, infrared light, and lots of math. These tools let us map the spiral arms, track star motions, and even simulate what the future might look like. Meanwhile, our Sun is just doing laps around the galaxy's center, taking about 225 million years per orbit. That means, since it first formed, it's only made about 20 trips. Last time we were in this part of the galaxy, dinosaurs were just getting started. So what actually builds and holds galaxies together? 3 silent architects: gravity, dark matter, and black holes. Gravity, the great collector, has been pulling matter together since the Big Bang. Dark matter, it's an invisible halo surrounding every galaxy, keeps stars from flying off into space. And in the middle of nearly every large galaxy, including ours, sits a supermassive black hole millions or billions of times the Sun's mass. Far from just destroying things, black holes regulate star formation, shaping how galaxies grow. Together, these unseen forces sculpt the cosmos. Galaxies may look calm in photos, but they're constantly moving, orbiting, and sometimes colliding. These encounters aren't violent explosions, but slow-motion dances that last billions of years. Next time you look up at the stars, remember the beauty you see is only half the picture. The rest is invisible, but it's always there, holding the universe together. Despite their vastness, galaxies are mostly empty. Stars are so far apart that even when two galaxies collide, direct star crashes are almost impossible. Think of it like two clouds of mist drifting through each other, except the mist is stars, gas, dust, and dark matter shaped by gravity. But collisions still leave scars. Galaxies stretch and twist, forming tidal tails ribbons of stars flung across space. Gas clouds slam together, sparking bursts of starbirth, creating what astronomers call starburst galaxies. Some of the most stunning galactic shapes we've seen, like the antenna galaxies, are caught mid-collision, glowing with newborn stars. Spirals rarely survive these encounters. The graceful arms are too fragile. After major mergers, galaxies often settle into huge ellipticals, their stars' orbits scrambled, their gas burned up or expelled. Many of the largest galaxies we see today were built this way through slow-motion crashes, not calm growth. And our own Milky Way isn't exempt. It's currently tearing apart and absorbing smaller galaxies, like the Sagittarius dwarf. Far bigger, though, is the inevitable meeting with Andromeda. Right now, it's 2.5 million light-years away, drifting toward us at about 110 kilometers per second. In 4 billion years, the two will merge into something entirely new, perhaps a giant elliptical. Surprisingly, the stars in both galaxies will mostly glide past each other unharmed, though the night sky will transform in spectacular fashion. This cosmic dance isn't rewrites the rule. Galaxies grow through collisions, blending, reshaping, and sparking new generations of stars. Destruction and creation go hand in hand, leaving behind something greater than before. And remember, every time we look at the sky, we're not seeing the present, but the past. Sunlight takes 8 minutes to reach us. Alpha Centauri's glow is 4 years old, and Andromeda's shimmer began its journey to 0.5 million years ago, long before humans existed. With telescopes like Hubble, we can look even deeper, billions of years back, nearly to the dawn of galaxies. Every photon is a messenger from history. You gaze upward, you're not just stargazing, you're time-traveling. Light that reaches us today has traveled for billions of years, crossing unimaginable distances before finally landing on Hubble's mirror. That's why telescopes are often called time machines. They capture memories written in light. Now, with the James Webb Space Telescope, we can see even deeper into the past. Its massive 6-meter mirror and infrared vision allow it to detect the earliest galaxies. Light has been stretched by the expanding universe into longer wavelengths. Webb is already revealing chaotic young galaxies, and surprisingly, some that look far more developed than expected. These discoveries are forcing astronomers to rethink how quickly the first galaxies formed. Here's the poetic twist. The farther away something is, the younger it truly was. Yet the older it appears to us, because we're seeing it billions of years in the past. Every photon that reaches Earth is a message from history, carrying the memory of a star, a cloud, or a galaxy. Science, in many ways, is just learning to listen more carefully to those whispers of light. But there's a horizon. Beyond the cosmic microwave background, the afterglow of the Big Bang we can't see. Back then, the universe was opaque, trapping light until it cooled enough for atoms to form. That ancient glow marks the edge of our cosmic vision. Beyond it, pure mystery. Still, what we can see is extraordinary. Every Hubble and Webb image is a snapshot of time moments from when Earth was young, long before humans existed. That light has crossed space and time just to meet us here. The stars above you aren't just shining, they're remembering. Step back further, and galaxies reveal an even larger story. They rarely live alone. They gather in groups and clusters, tugging on each other with gravity. Our own Milky Way belongs to the local group, alongside more than 50 galaxies, including our future dance partner Andromeda. Together, they're part of the Virgo cluster, and beyond that, the massive Laniakea supercluster home to about 100,000 galaxies. On the grandest scale, galaxies trace patterns in a vast cosmic web with dense filaments and huge empty voids. It's the skeleton of the universe, sculpted over billions of years by dark matter and gravity. Yet not all galaxies are still alive with starbirth. Many giant ellipticals have burned through their gas and now glow with aging red stars, quiet, fading, but still magnificent. Even our Milky Way is slowing down, past its peak era of star formation. Meanwhile, the universe itself is expanding faster and faster. It's pushed outward by something we don't yet understand. Dark energy. The cosmos isn't just a place, it's a story in motion. And every time we look up, we're looking back. Dark energy is slowly stretching the universe apart, sending galaxies drifting away faster and faster. Someday, far in the future, many of them may slip beyond our reach, their light stretched until it fades forever. But that's trillions of years from now. For us, the cosmos is still alive with motion, collisions, and dazzling surprises. With Hubble, Webb, and the telescopes yet to come, we are listening to the echoes of creation, catching light that began its journey long before Earth even formed. Every star, every galaxy we see, is a story written in photons, some still unfolding, others long finished, yet all part of the same grand design. Across this journey, we've watched galaxies ignite with new stars, collide and merge, grow old and quiet. We've wandered through the Milky Way, glimpsed the pull of black holes and dark matter, and looked back to the very first sparks of light. In every step reminds us that we, too, are part of this story. The atoms in our bodies were born inside ancient stars. We are not just looking at the universe, we are made of it. Maybe that's why the night sky feels so comforting, why silence falls when we look up. Some deep part of us remembers that starlight is home. So as we close tonight's journey, I'll ask again, where in the world are you listening from? Share a note if you'd like. These cosmic travels connect us, scattered though we are, bound by curiosity and stardust. If you enjoyed this quiet drift through the cosmos, feel free to like or subscribe. There are countless wonders still waiting. For now, let the stars keep watch, and let the galaxies keep spinning. Rest well, fellow traveler.